start this recording. Okay. Good. There. So last day, right, we talked about annuities due, which is just when you have payments at the beginning of each payment period, right, and how our formulas change. And we talked a lot about that, and so I'm not going to really review it. There's a video for that. And so what I'm going to do now is just going to jump into perpetuities. We also talked about some special case annuities, right? So one of them being a deferred annuity, things like do not pay until February 2020, things like that where, okay, so you get this loan essentially, but then you wait, so you defer, and then you start paying in February 2020, right? That was taken from an ad that I heard on the radio, so I thought that's a pretty good example. And so that would be a deferred annuity, and that just combines our what do I want to call it? The word's not coming to me. The compound interest section with our annuity section. I don't know why that didn't come to me. Anyways, so that's all in the notes from last day. Today, we're going to do 7.3, which is perpetuities. If I had to pick a favorite part of this course, it's teaching you guys about perpetuities, because I think they're a really fun idea and a really fun thing. So the idea is you deposit some amount of money, right? And remember, in compound interest, right, it sits there, and then we would add the interest on, and then we would keep earning interest. In perpetuities, what we do instead is at each compounding, we take the amount of interest that we would have earned, right? And we just live off the interest, right? So if every month, for example, our investment is making $200 in interest, we would skim that off the top. And then so our principal would stay the same all the way through. That way, these payments can keep going forever and ever and ever and ever. I think that's kind of cool. Perpetuity, perpetual is forever. So a perpetuity, right? Think perpetual, which is forever. We skim the compound interest off of the principal amount at each payment, or sorry, at each compounding, skipping ahead, at each compounding to get payments forever. Woohoo. Which is a really fun thing to think about. If you've been playing along on your formula sheet, right, then we have covered all the formulas except for the bottom two, which is a present value of a perpetuity and a present value of a perpetuity due. The difference between those isn't that big, right? We can have a look and probably even figure out why there's a difference in these formulas, right? We'll talk about them, but for now, let's just say that the present value of a perpetuity we see as just the PMT over I. Okay. So just some notes here, just like we did before, kind of slicing and dicing this formula, where the present value of the perpetuity is how much principal we'll need, right? How much do we need our initial investment to be in order to sustain these payment amounts, right? So how much principal we will need, right? I'll just say in brackets, initial investment amount. The PMT is the periodic payment amount. Periodic payment amount. Right. So how much we want our payments to be, or how much they're going to be if we just have some amount that we're investing. And I, of course, is the periodic interest rate. Usually, though, we'll have to find I2, just like before with annuities. So I is the periodic interest rate. I'll do in a different color here. We might need to adjust I, right, to match the desired payment frequency, right, which is essentially saying find I2. We might need to adjust I to match the desired payment frequency which means we need to find I2. But other than that, this formula is so much simpler than what we have been using, right, for annuities, that just makes it really fun. Like a fun detour. And as you might have guessed, right, so that's the second to last formula, if you will. And then our very last formula is just if we need our payments to be at the beginning of the payment period, right, we need to be ready with that first payment amount. And then the rest will take care of itself, right, with the other formula. So if payments need to come out at the beginning, I'll underline that, of the payment period, we use the present value of a perpetuity due is, again, the PMT over I, where the present value, the PMT and I are the same as up above, right? But to make it due, we have to add the PMT. And I'll just make a note here. This is because we need to have the first payment ready. Payment. Oh. Ready. That doesn't say ready. That's the only difference between the two, right? Our present value has to be whatever makeup we need to have PMT over I, but then also have that initial payment, and that's the only difference between these two. Right? Any questions about that before we do our example or an example? Okay. 232. Okay. So this one, it is combining the idea of a deferred annuity with a deferred perpetuity, right? And so we are kind of stepping it up a notch. But here we go. So a donation of $350,000 is made to support youth sports in Kelowna. In order to hire a part-time administrator, the organization requires $25,000 annually at the beginning of the year in perpetuity, right, forever. How long should the organization invest the $350,000 for at a rate of 5.5% interest compounded semi-annually so that they can hire the administrator? Okay. So what I want to do here is, first I want to make up the timeline, right? Whereas before we were just highlighting the compoundings per year, the payments per year. And I guess we can still do that, but because we've got two parts, it's going to be easier if we just make the timeline and look at the payments per year, compoundings per year separately. So we'll start making our timeline here. I did a little arrow at the end, only because I know that I'm going to have a perpetuity here, right? Because I need to sustain these payments forever. So we'll start today. And then for some unknown amount of time, this $350,000 is going to sit here. Okay. Until at some point, it can sustain annual withdrawals of $25,000 in perpetuity, right? Meaning the interest off of this block has to be $25,000 at the beginning of each year, right? And so if we just put a 0 years mark here, and then 1 year, 2 years, and for perpetuities, I just want to see the first 3 ticks. Same as an annuity, right? I want to see the first 3 and the last 2. But because these go on forever, there are no last 2, so just seeing the first 3 is enough. And then I'll just do ... And then I'll just highlight that these go on forever with this arrow. So we want $25,000 annually at the beginning of the year. So to show that it's at the beginning, we have our first payment of $25,000 at the 0 year mark. Whereas if it was at the end, right, then this would be at the end of the payment period. Our payment would be shifted to here, right? So we just think of, okay, here's the beginning of the payment period, here's the end, and that's where we're going to put our payment. So then we're going to have basically the interest that we're skimming off the top forever, bless you, is 25,000. And it just keeps going and going and going and going. Okay. These, we can use these amounts, right, to figure out, okay, well, how much do I need in order to have that happen, right? In order to have 25,000 coming off in interest at the beginning of each year. And so same idea as the annuity, these are going to funnel back to the 0 year mark, to the present value of a perpetuity due. And in terms of how I'm going to do these calculations, right, I'm going to start with everything that I know, and then I can solve for the perpetuity due, and then I can use that to solve for how long it is between today and the 0 year mark, where we start getting payments. So what we have, I'll just put a little subscript 1 on the perpetuity due to say that's the first thing I'm going to calculate. And then this 350,000 is going to be a future value. That's actually going to be the same as the perpetuity due. And on this arrow, I'm going to try to figure out how long it is between today and the 0 year mark. All right, that's our goal. So how long does it take for 350,000 to grow to whatever the present value of the perpetuity due is? Because that's when we'll be able to start getting these payments. Interest is compounding semi-annually. And that's for both of these. What could happen is, okay, the first section where it's just sitting and it's invested in a savings account and just growing, maybe that's at 3%, and then the perpetuity is at 2%, something like that, right? That could happen. But in this case, it's just across the board. Our compoundings per year is semi-annually. For the perpetuity section, right, our compoundings per year is 2, and our payments per year, we've got annual payments, right, is 1. Remember, we have to adjust for I1, or so I2, sorry. So the compoundings per year is our F1, and our payments per year is our F2. So since the compoundings per year is not the same as the payments per year, we need to find I2, which means we have to find I1 first. So I1 is R over F1, which was 5.5%, so 0.055 divided by 2. Did I bring it? I did. 0.055 divided by 2 is 0.0275. So I2 is 1 plus I1 to the power of F1 over F2 minus 1. If you don't have these formulas memorized, I don't know. You don't have to, but because you have your formula sheet, but it's kind of hard not to. So this is going to be 1 plus 0.0275 to the power of F1, which is 2 over F2, which is 1 minus 1. So plus 1 to the power of 2 minus 1. I2 is 0.0557625. And I'm going to store this in 1. As a check-in point, this is very close to 5.5%, right? The difference is that, okay, well, we moved from 5.5% compounded semi-annually to compounding annually. So we don't actually expect there to be a big difference here, right? Between the 5.5 and the 5.575, right? So that's a good check-in point, because if you're getting drastically different values, then that might be a clue that you did something wrong, right? So just make sure that your periodic interest rates actually make sense, especially when we're going to an annual compounding, that it's easy to kind of check. Okay. All right, so we just saw the beauty of the calculator functions last day, but there's no calculator function for the present value of a perpetuity due. So we have to do it by hand, but it's not that bad. So now we can find the present value of a perpetuity due is the payment amount over I plus that payment amount again, which is, we need a payment amount of $25,000. 25,000 over, now if you want to write recall 1, that's fine, as long as you've told me what you've stored in 1, but because it's only 1, so I'm going to write it out, 0.05575,625 plus that first payment as well. So if I take 25,000 divided by recall 1, I have to have 448,380.2264 plus that first payment just has to be ready to be taken away right away, right? So it's not really contributing to these future payments, but it has to be ready to go. And so plus 25,000 puts us at 473,380.2264. In terms of money though, 2 decimal places, 473,380.23. Okay. Cool. So if we just have a glance back at our timeline, right, we've said that, okay, I need to have $473,000-ish, right, $380 or something like that, in order to sustain these payments, right? So now I know how much I have to have. That kind of turns into a future value. So now all we're trying to figure out is how long does it take for 350,000 to grow to 478 or 3,000, whatever it was, 473,000, right? So that is just a compound interest problem, right? It's not crazy. It's just that we've tied the two together. Okay. Because it's our first one, I'm going to do a little explanation, which you wouldn't really have to do on your test, but we would need $473,380.23 in the bank to be able to withdraw $25,000 at the beginning of each year in perpetuity. Forever. Mostly because I want to emphasize that perpetuity just means forever. These payments go on forever, right? And that is because we're not actually taking away from the principal amount. That principal amount stays the same for each period, right? We're just skimming off the top whatever interest we would have made. So now we need to figure out how long it would take 350,000 to grow to that amount. How long it would take $350,000 to grow to $473,380.23. You know how to do that. You could even use your calculator if you wanted to, right? I'm going to do it by hand, right? But you definitely could use your calculator. But for compound interest problems, right, where there's no payments, I don't know, it's kind of, I think it's easier to just use your formulas, but hey, whatever works. So now, from the compound interest section, right, you know that n is the log, the natural log of the future value over the present value. Divided by the log, the natural log of 1 plus I. You've got options for I. You could use I1, but then you'd have to remember that your frequency, right, n is the number of compoundings, so then your frequency would be 2, right? Or we can use I2, which has a frequency of 1 already. It's just a matter of taste. So just make a little note here. We can use I1, right, where f equals f1, which is 2, right? Or we can use I2, where f is f2, which is 1. What is this course and how do I teach it? I want in on that. I guess it is what you make it. We could watch videos too, but you wouldn't learn a lot. Well, maybe you would. So bizarre, right? So depending on which I you choose, it's fine either way. You're going to get the same answer, right? But you want to be careful because your n is the number of compoundings, right? So n is the number of compoundings, right? We want to figure out how long it's going to take, right? So that's going to factor into finding t. Right? I'm going to go ahead and use I2 because it's already at a frequency of 1. Right? So I'll make a note here. I will use I2. So I have the log, the natural log of $473,380.23 divided by, well, I need to scoot this over a bit. divided by 350,000. And then that's divided by the natural log of 1 plus, you could do recall 1 if you want, right? Or 0.05575625. So I've got 473,380.23 divided by 350,000. And then I'd want to take the natural log of that. So I end up at 0.30196578. I'm going to store this into mostly making a note to myself, right? So that I know where to go back to. Divided by 1 plus recall 1. And then the natural log of that is 0.054257335, which I'm going to store in 3. Those are more notes to myself than anything else. If you even skipped straight to the answer, that's fine by me, right? You don't have to do this middle step. This is more to show you and to make sure that you're getting the same answers when you do it on your calculator, right, as I'm getting. So now I'm going to do recall 2 divided by recall 3, and I get n is 5.5654370028. Just making a note that this is compoundings, right? And this is where we reflect back on, okay, well, what was my compounding frequency for this I that I used, right? Depending on which one you used. And so we can't have it sit there for 0.565 of a compounding, right? So we would need to go for a full 6 compoundings. We would need to let the investment sit for 6 compoundings. Since we're assuming in this course that we can't just pull it out after a fraction of a compounding, right? So since we can't withdraw our funds at 0.565437028 of a compounding. And we've used that idea before, right? That n, you always round up to the nearest whole number. So we would have to sit for 6 compoundings. And then if we remember that n is time times the frequency, here, this frequency, f must match the I you used, right? I used I2, and I2 has a frequency of 1. And so if we have 6 is time times 1, right? T would be 6 years. So now, if we have a look at our timeline, now we're saying, okay, well, the donation we invest it, 350,000, it sits there for 6 years. After 6 years, it'll be able to sustain payments of 25,000 every year at the beginning of each year forever. Pretty cool idea. Someone told me, this was a while ago, but someone told me that a bank does do perpetuities, but a perpetuity is 72 years or something. So they do them. It's just not forever. But they'll go, I don't know, 72 years. It's pretty good. So you can do perpetuities, which is pretty cool. Any questions about that? Okay. Just as a heads up, if you're kind of flipping through the textbook, we're not doing section 7.4, which is constant growth annuities. Oops. It's kind of another special case. I picked perpetuities because I think they're the most fun. So we're not doing constant growth, and we're not explicitly doing section 7.5, which are special case annuities. You have the tools that you would need to do these problems. It's just not something that I would expect you to do. An example being, okay, if you want to have a full amount saved up so that you can buy a coffee that costs $2 every day for some amount of time for 20 years, every day except for Sundays, for example, right? Then you could figure out, okay, well, how much do I need to have those $2 a day every day? And then how much would I need to subtract for the Sundays that I don't need, right? And that would be a special case. So you have those tools. We're just not going to talk about them because it's not going to come up on test 3 or the final. So it's more just for fun. Yes. How far? More?
Yeah.
How about here?
Yeah.
Good.
So for the last step there with the compoundings, I'd have to bump it up to 6 then? And then...
That's right. So whenever you have an n, your n always has to get bumped up to the nearest whole number. Regardless of what the decimal is, you're always going to bump it up to a whole number. Okay, so that's perpetuities in action. And if you're looking at your practice test 3, well, what do you know? Question 4 in the long answers looks a lot like that, right? So that's a pretty good hint that it will be on test 3 as well, right? So you'll want to get familiar. Okay. Any questions before we start chapter 8 on mortgages? There's only one section in chapter 8. Very exciting. This is where we kind of pull it all together, right, and talk about mortgages and just kind of amortization schedules. But there's no new concepts. It's just putting it into a different context. So chapter 8, mortgages. I'm going to go through and just give you the rules of the game for amortization schedules, and then we'll do one example, and then you'll be able to do some on your own. Okay? First off, an amortization schedule, amortization schedule is a schedule of payments, right, with the breakdown of the principal amount, the interest amount, and the remaining value, right, how much is left owing. So it's a schedule of payments with a breakdown of the principal amount the interest amount and the remaining balance. Okay. So maybe what I'll do is I'll sneak a screenshot of one of these schedules. So if you've got the mortgages handout that I just gave you, right, you've got, did you guys get the, no, let's see here. And then, so that's one each of those, and then a practice test each. Good. And then a practice test for you. Oh, here, hang on. Sorry, Ethan, I missed you. If you give those to that guy there, and then you can have these, and then these, and then that's good. Sticking together. Now, do I have these? I wonder. So what I'm going to do is I'm going to steal one of these, and then I'm just going to make notes on it about all the rules. Okay. These are just facts, right? Or I prefer to think of it as a game, and so these are the rules of the game, right? And I always think that the mortgage question on the final exam and on test 3, but definitely on the final exam, because then you'll have seen it once before, should be just the easiest 10 marks that you've ever had in your life. So here we go. The first payment number will always be 0. Okay? And so see in the first column here, you've got the payment number, the payment, the interest, the principal, and the balance, right? And so the first payment number will always be 0. With blanks across the first row until you hit the balance, and the balance is just going to be the total amount of the mortgage that you're getting. Okay, how much you're borrowing. So the first payment number will always be 0. with blanks across the first row except the balance, which will be the face value of the loan, which will be the face value of the loan. So what that looks like, right, is your payment number, you always have your first row is 0. And then we've got blanks, bless you, bless you, bless you. One for each blank. And then here, this value here is the total loan amount. If I tell you that you get a mortgage for 25 years and you're going to make monthly payments, how many payments are you making? That's going to be 25 times 12. And so 25 times 12, you would have your payment number 1, 2, dot, 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 all the way down to 300, right? You're making 300 total payments, right? And so your payment number is just going to be each individual payment number, just like it says. And so here, this is going to go 1, 2, dot, 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 to n minus 1, and then n. You'll have to find what n is. N is the number of payments, right? But just in general. Okay. The payment amount is the next column. Right? And so the payment amount, we can figure out if we imagine just one of those timelines that we've been doing, right? If we're given how much the loan was, how long we're going to pay it off for, and what the interest was, then we can figure out what the PMT is, right? And that's your payment amount. And so what I'm going to have as our second fact is that the payment amount, it's going to be the same for all of those payments except for the very last payment, right? That's where we have to square everything off, right? If there's a little bit left owing, or if, you know, we've overpaid or whatever, not necessarily overpaid, but it might be a little bit less or a little bit more than what we're used to paying, just to square it off. And so here, in general, you're going to have your PMT up to this last payment, remaining payment. So our second fact is going to be that the payment amount, your PMT, will be the same for every payment. Will be the same for every payment except the very last payment the very last payment where we will need to pay the remaining balance as well as any interest left owing, as well as any interest left owing. If we have a look at our next column is the interest. That's the interest amount. Now, the interest amount that we have to pay each time is going to be the previous balance, right? So the interest amount here is going to be the previous balance times I, or usually I2, because we'll be compounding at some frequency and our payments are going to be at another frequency, which means we have to use I2. And so here, our third fact is that the interest amount will be the previous balance times the periodic interest rate which is I. I'll put a little, we usually need to find I2, right? Because our compoundings per year and our payments per year aren't necessarily the same. We will often need to find / use I2. I2, and I'll just say, if our compoundings per year is not equal to our payments per year. That's the same rule as we've been using, right? And that is just the general rule for I2. Okay. In terms of kind of how can I do this? Well, if I denote a balance subscript 0, right? A balance at my 0th payment, then the interest here is going to be B0 times I2. Right? So that's just kind of showing you what I wrote out, right? It's the previous balance times the periodic interest rate. So then if this is balance 1, right, the balance after payment number 1, because we made a payment, some of that is going to go towards interest because we have to pay interest, but then some of it is going to chip away at the principal, right? And so then you're left with a new balance, and so the interest at payment 2 is B1 times I2, and so on and so forth. The principal amount is going to be the payment amount, right? The amount we paid. Then the bank takes away the interest. Whatever is left remaining is the principal, and that's what gets taken away from your balance, right? So the principal amount will be the payment amount which is your PMT, minus the interest amount for that row. So now, kind of showing you on our graph here, can zoom in. What color can I use? Pink, maybe. The principal amount for the first payment is going to be PMT minus the initial balance times I2, right? And then for the second payment, we're going to have PMT minus B1 times I2, right? But all I'm showing is that, okay, well, this amount here is going to be this minus this equals this. And so however you do it, and once you've done a few of these, you'll kind of get into the rhythm of things. And then finally, our balance at each of these points is going to be the previous balance minus the principal amount. Right? So, fact number 5, the balance will be the previous balance minus the principal amount. I guess if we want to get technical, right, then that would mean that B1, if we're finding the balance after payment number 1, and we're saying that that's the previous balance, that's B0, minus the principal amount, but the principal amount was the PMT minus B0 times I2. That might not be very helpful, right? The idea was to kind of break it down and make it easy, but just giving you options for how to think about these things, right? But what you'll find is that you're going to start with the first row of the table, figure out how many payments you have, what your payment amounts are, and then the rest of the table just kind of fills in itself. Are you going to have to do all 300? No, absolutely not. But I am going to ask for probably the first 2 or 3 payments, the middle 120th payments, let's say, right? We'll do an example and I'll show you how to do that, bless you. And then the last 2 payments, right? So we'll need to know how to handle that. But let's talk about the last payment, because what we said was that, okay, that last payment has to square off everything. And so if we're thinking about the amount of interest, well, we're going to be able to find the amount of interest, right? We're going to be able to find, okay, well, the principal that I'm paying has to be this amount, right? Because the total here has to be 0, right? So where we start for the last row is we force this to be 0, and then everything else just kind of has to get paid off, right? And so the rule here, rule number 6, is to calculate the last row. To calculate the last row, set the balance to $0, right? So we're done paying the leftovers to zero. Calculate the interest owing on the previous balance, right? So calculate the interest amount. So calculate the interest amount owing from the previous balance. Add this interest amount to the principal, which has to be the same as the previous balance. So maybe I should start there. The principal amount must be the same as the previous balance. Otherwise, our balance wouldn't be zero in the end, right? So it must be the same as the previous balance. The final payment amount, must be the amount of interest owing plus the principal. Must be the amount of interest owing plus the principal. And then one thing that I want to add, right, is that to find the balance at any payment number, we would calculate the future value after at that n, right? And so point number, or rule number 7, to calculate the balance at any payment number, instead of using n, how about I use k or some other letter, right? Just to denote any payment number that I want. K we use our calculator, right? You're gonna need to use your calculator functions for this, right? So we use our calculator You don't need to, but it's very hard to do by hand. So you're gonna wanna use your calculator. So we use our calculator to find the future value, at n equal to k. And this will make more sense once we do an example, right? But I just wanted to have it in the list of things. All the things. K, it's a lowercase k. But that's just my math talking. It's a cursive K, which is more to denote that it's just a random letter. Okay. 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 Ready for an example? Maybe, I guess we'll find out. So you've got the mortgages handout. I wanted to give you this printout. We're only going to go through the first one, right? And then you'll be able to do your written assignment to hand in at the end of class for completion marks. So we'll just do one, and then I'll give you time to work on the rest. Okay. So where was that little guy? Chapter 8 worksheet. Oh, forgot to bring it in. So, for example, we're going to break this down and just going to walk you step by step through each of these cells in the tables, right? And so Norm wants to purchase a home in West Kelowna for $308,000. He intends to make a $100,000 down payment, with the remaining payments being made bi-weekly over a 25-year period at 4.75% compounded monthly. This is all sounding like a problem that we know how to solve already, right? And it is. It's just that now we're applying it to an amortization schedule, right? So we know how to deal with these things. Construct a partial amortization schedule showing details of the first two payments, payments 324 and 325, and the final two payments. What are the net interest charges? So how much interest did he pay? Okay. So the first thing I want to do is, for these mortgages, we don't really do a timeline. We could, but that's not really the name of the game. But what we want to know is, well, the first thing is, how much is he actually getting a mortgage for, right? And so the mortgage amount is going to be the $308,000, but then minus the down payment, right? So he's not borrowing that $100,000. He's borrowing $208,000. So that's the first thing that you want to keep track of, because there is always going to be a down payment amount and then the loan amount. So if we wanted to draw this out as a timeline, and you definitely don't have to, we would start today, and he makes a down payment of $100,000, a loan for $208,000, and that's going to total $308,000. That's what we're told just by that little bit. So then he's making bi-weekly payments for a 25-year period. So I'm going to put 25 years up above here because my payments are actually bi-weekly, right? And so 25 times 26, I've got 650, and I'll just use BW for bi-weekly, right? Same thing as before. If I wanted to draw this timeline, I would put 649 bi-weekly here. Today I've got one bi-weekly, two bi-weeklies, and then I can fill it in with ... He's going to make payments made bi-weekly over a 25-year period. It doesn't say whether these payments are at the beginning or at the end of the bi-weekly period. The default is going to be at the end, right? If they're at the beginning, I have to say explicitly, these payments are at the beginning, right? If it's not clear like this, then they're at the end. Right? So at the 1 biweekly mark, he's going to make a payment, and then he's just going to keep going each biweekly. We don't know how much this payment is, but all of these are going to funnel back to make up this 208,000. And then our N is time times the frequency, which is 25 times 26, which is 650. Right. We already had that, but just for completeness sake. So like I said, you do not need to do a timeline for mortgage questions, but this is just to show you that you actually know exactly what's going on for these questions. Okay. All right. So what I want to do is, okay, so I'm compounding monthly and I'm making bi-weekly payments. So I'm going to make a note here that my compoundings per year is 12, which is my F1, bless you. And my payments per year are bi-weekly, so my payments per year are 26, which is F2. Since my payments per year and my compoundings per year are not the same, and they won't be, they likely won't be, I should say, I have to find I2, right? Which first means I have to find I1. So we need to find, so since our compoundings per year is not equal to our payments per year, we need to find I2. And so we need I1, which is R1 over F1, which is our 0.0475 divided by 12. 0.0475 divided by 12, I just did one. 0.0475 divided by 12 is 0.0039583333, which I'm going to store in 1. I get tripped up, don't I? Oh, maybe it makes sense. I1 is in store 1. I2 is in store 2. Store 1. So then I2 is 1 plus I1 to the power of F1 over F2 minus 1, which is going to be 1 plus, and I'm going to cheat and I'm just going to write recall 1, and you're allowed to do the same. As long as I've said what store 1 is, to the power of 12 over 26, and then minus 1. One plus recall 1 to the power of 12 divided by 26, and then minus 1. I get I2 is 0.00182498, which I'm going to store in 2. That's the I that I'm going to use to find the amount of interest at each point, right? So you really want to make sure that you've got that stored so you don't have to enter it every time, right? Because I need to find the amount of interest at 6 different points. The first 2 payments, the middle 2 payments, and then the last 2 payments, right? And so I'll need this handy. So I've got that stored in 1. Okay. Next thing we need to do before we can go ahead and fill in our table, right, is find the payment amounts. Now we need to find the payment amounts. PMT. I would strongly suggest that you just use your calculator for this, right? And so I'm just going to assume that you're going to use your calculator, and I'm going to list these going from left to right just to save us some space. And so we've got N interest per year, the present value, the PMT, which is the one that I'm finding, so I'll put a little asterisk there. The future value, the payments per year, the compoundings per year, and beginning or end. Last day we showed begin mode. In fact, my calculator is still in begin mode, so you want to make sure that you can change that. Okay. But for our N, we said N is 650 payments. Right? Our interest per year was 4.75. The present value has to be the loan amount, right? And so we've got 208,000. Remember, we have to keep track of if it's positive or negative, right? And so because we're getting this loan amount, right? Never mind that we're spending it on a house and it's leaving us, right? But in terms of your relationship to the bank, right? You got this loan amount, so it's positive coming to you, right? And now you have to pay it off, and that's money that's negative to you. And so our future value, once this is all paid off after 650 payments, our future value should be 0. We already decided that our payments per year are 26 and our compoundings per year are 12, and we're at the end mode. And I'm just going to make a note what I said earlier, right? It's the end, basically because it's not clear that it's at the beginning. Because it is not clear that it is at the beginning. If it's at the beginning, I'll have to be really clear about that. So now, if we use our calculator, right, we've got 650 for N, 4.75 for the interest per year, 208,000 positive for our present value. I'm going to come back and compute my PMT, 0 for our future value, 26 for my payments per year. Make sure you hit enter after so it stores it for our payments per year and our compoundings per year. And my compoundings are 12, enter. And then I have to change from begin mode to end mode. So then I go second begin mode, second enter. Now it's at the end. And now if I compute my payment amount, I get a payment amount of negative 546.730574. So each payment has to be $546.73. Therefore, each payment, I'll put in brackets, except the last payment, must be $546.73. So now I'm going to grab the table. Oh. And paste it in here. Can make it even bigger, actually. Wait. Come on. You can fill the page. Okay. Following those rules, right? Our first line, so the first payment that we have, payment number 0, right? And across the row, we're gonna have blanks until we hit the balance, which has to be the $208,000. Right. So now I need, so the question asks for, where did I put it? For the first 2 payments. So that's 1, 2. And then payments number 324 and 325. Before you jump the gun here though, what we need in order to find the amount of interest and the principal is the previous balance, right? And so in order to find the 324th payment, right, we would need to know the balance at the 323rd payment, right? So we actually need the one before it, 323, in order to find 324 and 325. And then we can ease up again, but same idea. If we want to find, and we know how many payments we have, right? We have 650 payments. And so if we want the last 2 payments, that means we need 650 and 649. But also in order to find 649 completely, we have to know what the balance is at 648. Our payment amount, we said for all of these except the last one, is going to be $546.73. So I'm going to put those in. $546.73, $546.73, $546.73, da 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 da. Until that last payment. That one will be a little bit different because we have to pay everything off. It'll be close to paid off, but not quite. Okay. For the amount of interest, what you're going to do is you're going to take the previous balance, right, times the I2 that you stored, right? And so you're going to have, and then round your answer to 2 decimal places properly. So if you have 208,000 times, and I put it in store 2, I want to say, just let me double check here, store 2, so times recall 2, rounding immediately to 2 decimal places, right? Because we are talking money, so we don't want to have anything left over. We've got 379.60, right? 0.5958 rounds to 0.60. That's how much we have to pay in interest, right, for that biweekly period. So now the principal is everything we paid minus the amount of interest, right? And so 546.73 minus 379.60 is 167.13. And then the new balance is going to be this previous balance minus the amount that we've chipped away at the principal, right? And so slowly but surely we're going to dig away at this balance. But we have to pay a lot of interest, right? Minus that guy. So I get $207,832 and 87 pennies. Now, if you keep that on your screen, right, you'll be able to find the amount of interest for the next line, right? Because that's the amount that you need times I2. So times recall 2, and rounding again to 2 decimal places right away, I get 379.29. So we're paying just a smidge less in interest than we were previously, right? Because we've got a smidge less owing, and so that's how it's gonna keep shifting. And by that same idea, right, the amount that goes towards the principal is gonna increase as we pay off and have less interest coming out. So 546.73 minus 379.29. Now we've got 167.44 going towards the principal. And so that's chipping away at the 207,832.87. So now I owe 207,665.43. These keep going. And we won't know at the 323rd payment, we won't know what the interest and the principal are, right? Because then we would need to know the previous payment. But the game here is we're gonna find what the future value is at 323 payments. Yeah. So here, I'm gonna say, okay, I'm going to explain this green box down here. So this is the future value at n equal to 323. So what we do is you don't have to change a lot in your calculator, right? But we do have to say, okay, well, now I know what my payment amount is, right? So if we think about how our calculator is in n interest per year, present value, payment amount, future value, payments per year, compoundings per year, and beginning or end, right? Things that aren't changing, we don't have to re-enter, right? But now we're saying, okay, well, n is going to be 323 instead of 650. The interest per year is going to stay the same, 4.75, I think. Yeah. The present value is still going to be 208,000. And the payment amount has to be negative, right? Because we are making payments to pay off this loan. So negative 546.73. Now it's the future value that I'm solving for. And our payments per year and our compoundings per year stay the same. So 26, 12, and end. I'll just highlight the ones that changed, right? This one changed. This one changed. Right? Everything else stays the same. And now we're finding the future value. So now I'm going to put in 323 for n. I'm going to leave all the other ones because they're not actually changing. And then I'm going to make my payment 546.73 negative, and now I can compute my future value. My future value, if I were to just pay it off, right, that is the idea of the balance. The future value is $134,546.11. Negative 134 546.1137. Right. And so we have 134, and I'm going to put a green box around this in just a second. 134,546.11 goes in that green box. $134,546.11. Making sure that you use the rounded value. Now we can take that times I2 and find the amount of interest, and then we can find the principal, right? And so basically what happens is that once you have this future value, then this section is basically the same as that section, right? And same thing here. If we need to look at the last two payments, I need the future value at n equal to 648 in order to calculate the rest of them, right? So if we just kind of go through and do these middle two payments, 134,546.11 times recall 2, rounding to 2 decimal places, I get 245.54. $546.73 minus 245.54. 301.19. Really hoping I'm not doing little errors here. Phew. And so the previous balance minus 301.19 is 134,546.11 minus that previous answer, 134,244.92. That times recall to 244.99, 546.73. And I know some people like to store these different values, like the 546.73, because we use it a lot. You can store that somewhere. I don't think it's that big of a hassle to just punch it in, but what do I know? 301.74, 134, 244.92 minus that previous answer, 133.943.18. And then it just keeps going and going. Now let's do this all over again. We don't know what the interest or the principal are at the 648th payment, but we can find the future value there. And so same idea here. This is the future value at n equal to 648. Now the only thing that changes in your calculator, right, it's even less because you've got that payment amount and it hasn't changed. So now the only thing that's changing is your n. So n is now going to be 648. Interest per year, present value, PMT. Future value is the one we're calculating. Payments per year, compoundings per year, beginning or end. Interest per year stays the same, 475, 208,000. Payment negative 546.73. Calculating the future value, 2612, end. Highlighting the only thing that changed now from before is that 648. So even though it looks like a lot of work, it's actually not. So now 648 for our n, compute the future value. Now the future value that I'm owing is 1,091.185749. So in that purple box, we have $1,091.19. Now I can use that to find the interest amount, 1,091.19 times recall 2. Now I'm paying $1.99 in interest. That sounds better. And so 546.73 minus $1.99, 544.74, 1,091.19 minus that guy, 546.45. Here's where things change. Okay. So before we would have taken this, found the interest, which we're still going to do, right? So let's start there because that's what we would have done usually. So times recall 2, because we still have to pay interest, right? I get 0.997, which I have to round to a whole dollar. Okay. So we still have to pay that dollar in interest, but this balance has to be 0, right? Which means that this amount has to be the amount of principal that I'm paying, right? So things kind of change in this last payment line because we have to square everything off. So we're forcing this to be 0, and we're forcing this to be 546.45. So instead of taking the payment amount minus the interest is the principal, now we're adding up our interest and our principal to make up our final payment of 546.45 plus 1, 547.45. Okay. So this is our partial amortization schedule. The last part that we wanted to answer was, what are the net interest charges, right? So how much interest is Norm going to pay? So the amount of interest is, if you sum up all your payments, right, which is 546.73 times 649 plus that last payment of 547.45, and then you take away the 208,000, right, because that's how much you borrowed. Everything over that is going to be interest, right? And so the total interest paid the total paid is 546.73 times 649 plus the last payment of 547.45. Just to highlight here, these are the first 649 payments. This is the last payment because it's slightly different. So this is going to be, if we add these all up, 546.73 times 649, I get 354,827.77 plus 547.45, making $355,375.22. So the total interest paid is the total paid minus 208,000. So that minus 208,000. So then we have 355,375.22 minus 208,000 puts us at 147,375.22. So $147,375.22 was paid in interest. Oops. Ta-da. Any questions? Okay. So I'm going to stop the recording here, but I'll come back to this. Don't worry, because I know you're still.